In this video, we're going to focus on how to find domain of a function. So basically, there's three big domain restrictions on a function in algebra. First one, denominator cannot equal to zero. If denominator of a function becomes zero, the function becomes undefined. So denominator cannot equal zero. Second, even radicands in the even roots must be positive only because square root of a negative number is not a real number. So in order for us to have a real output, domain is all the possible x values that give us real output values. That's what domain is. So domain is a set of possible x values which give us real output y values. So for an even root, we want to have inside radicand positive only. For odd roots, we don't care because for odd roots, you can have a negative or positive radicand, you will still have a real output. For example, cube root of negative 64 is negative 4, but square root of negative 64 is not a real number. Next restriction is logarithms can be only taken of positive values. Log of 0 or log of a negative number does not exist. So if you have a logarithmic expressions, doesn't matter what the base is, whatever you're taking the log of should be positive only. In word problems, physical or other real life restrictions might be imposed. For example, time can never be negative, distance can never be negative, number of quantities can never be negative. Let's look at some examples of finding the domain of a function. So first example, we have an absolute value function. Seems like it's never going to be, it doesn't have a denominator, so I don't have to worry about denominator being 0. There's no root, no radical even root involved, so no danger of having a negative inside an even root. And there's no log involved, so domain in this case will be all real numbers or from negative infinity to positive infinity. The next case, domain 5 minus 4x, we want it to be, we have a radical in the denominator and we want to make sure it's positive only. We want 5 minus 4x to be greater than 0. We don't want it to equal 0 because it's in the denominator. If 5 minus 4x radical was not in the denominator, it was okay if we would have put it equal to 0 as well, because square root of 0 is still a real number. But in this case, it's in the denominator. So 5 is greater than 4x, or 5/4 is greater than x, or we can say x is less than 5/4. So anything from negative 5/4, not 5/4 is my domain because we cannot have 0 in the denominator. Next, f of x equals x over x squared minus 4. So I'm going to split factor the denominator. Now we're okay with every single x value other than x equals positive 2 and negative 2 because that will make my denominator 0. So the domain in this case would be negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. Next example, we have a rational function and we want to make sure the denominator is not equal to 0. So we want to start by plugging in 5 minus 3x. Actually, we don't want it to equal 0. We don't care if it's negative. It can be negative. We just don't want it equal to 0. So we know that only value that can make it equal to 0 is x equals 3/5. And we don't want x equal to 3/5. So that means my domain in this case would be negative infinity to 3/5, union 3/5 to infinity. All the other values are okay. All the other x values are okay other than 3/5 in this case because 3/5 makes my denominator 0. Next example, we have a radical and it's an even root, it's a square root. So whatever is in the radical, we want it to be greater than or equal to 0. So x greater than equal to -1, that means starting -1 to infinity, that's going to be our domain here. Next function, we have a cube root. For cube roots, there is no restriction. You can have a negative inside a cube root. It's still going to give us a real output. So domain in this case would be negative infinity to positive infinity. Next example, we have a quadratic in the denominator and we have a radical in here as well. So we want it to be greater than equal to 0. Let's go ahead and factor the quadratic first. So x minus 5, x plus 1. That's what the factors will be here. So whatever is inside the radical, we want it to be, first of all, based on the denominator. If there was no radical, the restrictions would have been, you know, if there was no radicals, then we could say that other than x equals -1 and x equals 5, we are okay with everything. But in this case, we want x squared minus 4x minus 5 to be greater than 0. We don't want it to equal 0. We want it to be greater than 0. And that's a nonlinear inequality. We know how to solve nonlinear inequalities. X squared minus 5x plus x, which will give me, yep, that's right. So now to solve this nonlinear inequality, I'm going to go ahead and it becomes 0 at -1 and +5. So I'm going to see the sign chart. I'm going to make a sign chart for this nonlinear inequality. If I plug x as 0, then I do have something negative. If I plug x as 6, I have something positive. If I plug x as -2, I have something positive again. So that means my solution for this inequality is here and here. But because I have a radical involved, we cannot, so solution would be here and here. So that means all the x values either to the left of -1 or to the right of 5 are going to be okay. They are going to give me a positive inside positive radicand only. So my solution here is going to be -infinity to -1 and no equal sign. We don't want to include -1 because we don't want it to equal 0, and then 5 to infinity. That's going to be our domain in this case. You can always plug some values, try to verify if it looks right, if it doesn't, if it makes sense to you. So if you're worried about the negative values, go ahead and check by plugging in, let's use a different color. You can plug in x as -2 and see what happens in here. So you would have square root of -2 squared is going to be +4. -4 times -2 is going to be +8 minus 5. You will have a positive radicand here, which is going to be 12 minus 5, 7. So it's okay. You're not going to have negative radicand, all right? So this is going to be your domain. Next one, we have a square root in the numerator and we have a quadratic in the denominator. So let's see how do we figure this one out. Square root in the numerator. This numerator tells me that I need to have x greater than equal to -3 only, because you can have a 0 in the square root. So all the values greater than -3 are fine. And the denominator, if I factor, it's x minus 3, x plus 1. And denominator tells me x cannot equal 3 or -1. So that means my domain in this case would be from -3 to -1 union, -1 to 3 union, 3 to infinity. That's going to be the domain in this case. Next, we have log to the base 5 of x minus 3. Whenever we're thinking about log functions and domain, it does not matter what the base is. Base can be 2, 10, 5, anything. Base can be 1/2. But we cannot have we cannot take log of a negative number. So whatever we are taking log of, that has to be positive only. It cannot equal 0. It cannot be less than 0. So x greater than 3. That means my domain in this case would be 3 to infinity with parentheses around. Next, we have f of x equals log of x squared minus 1. So in this case, whatever we are taking log of, x squared minus 1, has to be positive only. Again, it's a nonlinear inequality, and I'm going to factor it and make the sign chart. So, sorry, this is going to be +1, not -1 here. So make the sign chart and see where is it positive. If I choose x to be 0, this inequality is going to be negative. If I choose x to be 2, the inequality is positive. If I choose x to be -2, negative 2 plus 1, and the negative times negative will be positive again. So in this case, I'm okay with everything to the left of negative 1, everything to the right of positive 1. So my domain would be negative infinity to negative 1, union 1 to infinity. It's all about domain of a function.